When early thought about the notions of relativity began, most scientists considered space to be empty, and since empty space could seemingly contribute nothing to mass, the nature of which is still unknown to science, motion through space at any speed could not logically contribute anything to the mass of an object. But when accelerator experiments began to indicate that particles certainly behaved as if their mass was increasing with velocity, the mystery even puzzled Einstein. Consider the following story. A working woman wasn't feeling well and took the rest of the day off. She arrived home earlier than expected and found her husband in bed with another woman. He sits up in bed and declares, "I love you. I have never cheated on you." His wife replies angrily, "You're lying. You're in bed with another woman right now. I can see her." Well, disappointed, he replies, "Are you going to believe me or your own eyes?" Einstein must have had a similar argument going on in his own mind when he was considering the apparent increase in the mass of a particle due to an increase in its velocity. He even had an equation where lowercase m was what he called the rest mass of a particle, uppercase m was the apparent increased mass of a particle when it was moving at velocity v. Particle accelerator experiments seemed to validate the equation, but fundamental nature of mass was still a mystery. The Michelson-Morley experiment seemed to prove that space was empty, so accelerating a particle through the vacuum of space would seem to contribute nothing to the mass of a particle. And yet, somehow, mass seemed to increase with velocity. And he had an equation. On the other hand, since he thought space was empty, why would velocity have anything to do with mass? And besides, we don't really know what mass is. Still, we see mass change in our experiments. On the other hand, maybe it's not really mass. Perhaps it's just an expression of momentum. Well, it seems so much like mass, it has to be related. Okay, then let's just call it relative mass. But we see mass change and we have an equation. Are you going to believe me or your own eyes? Well, in this example, Einstein did not believe his own eyes. According to Wikipedia, in 1948, Einstein wrote to a friend and said that it is not good to introduce the concept of the mass of a moving body for which no clear definition can be given. It is better to introduce no other mass concept than the rest mass, lowercase m. Instead of introducing uppercase m, it is better to mention the expression for the momentum and energy of a body in motion. Well, apparently he had no doubts about the accuracy of the equation. He just did not understand the true nature of mass and how velocity had anything to do with it. So, to be conservative, he decided to consider the mass change equation as an expression for the momentum and energy of a body in motion. He also assumed that the rest mass, m, was the only real mass of the body, regardless of its motion. And he also assumed that there actually was such a thing as rest mass. Now, this uncertainty about the true nature of mass and the assumptions that followed established the framework for the early discussions about relativity. Einstein's lack of certainty about the nature of mass could have easily led to a different conclusion. Consider some duck wisdom. If it looks like a duck, and waddles like a duck, and quacks like a duck, then, in all likelihood, it really is a duck. Likewise, if the equation shows that mass increases with velocity, and experiments demonstrate that mass increases with velocity, then, in all likelihood, mass really increases with velocity. And while this would have been the correct choice, their understanding at the time was incomplete. It was a coin toss. Heads would have headed them in a better direction. Tails introduced a false notion of relative mass, And that led Lorentz to assume that the notion of length contraction might actually be real, and it turned relativity discussions into imaginary parlor games, all because the discussion framework was based on a few wrong assumptions. Now, this framework was the basis for Lorentz's work explaining the notion of length contraction, which is explained in Wikipedia as followed. If you can accelerate a rod to speeds significant to c, then an observer at rest would see its length contract. Scientists claim to prove the validity of this concept using interferometers, but it is fundamentally the same experiment performed by Michelson and Morley over 100 years ago. Their interpretation of that experiment led to the wrong conclusion that space was empty. More recently, some scientists have, for other reasons, concluded that space is completely filled with atoms, 4.9%, dark matter, 26.8%, and dark energy, 68.3%. So, is space really empty, as some scientists believe? Or is it full, as others believe? Does mass really increase with velocity, or does it only appear to increase with velocity? And what is mass, really? Well, scientists lead the search for fundamental truth about the nature of things that are all around us. They probe big things like stars and planets that fill the sky above us, and small things like birds, bees, bugs, and butterflies. Their discoveries and related inventions have paved the way for a life that is easier, safer, healthier, more comfortable, more fulfilled, more entertained, and better traveled for many people on this earth. Because of this track record of such remarkable success, scientists have imagined that, given enough time and money, they will be able to probe even deeper and solve the remaining mysteries, both big and small. They have adopted a name for their pot of gold at the end of this ambitious rainbow. It is called the theory of everything. Wikipedia defines a theory of everything as a final theory, ultimate theory, or master theory. Supposedly, it is a hypothetical, single, all-encompassing, coherent, theoretical framework of physics that fully explains and links together all physical aspects of the universe. Finding a theory of everything is one of the major unsolved problems in physics. Such a theory would, no doubt, answer those, as yet, unanswered questions. Some scientists argue that such a theory cannot possibly be developed. Even if a candidate theory ever emerges, it will be impossible to prove mathematically. And I fully agree. Finding a theory of everything is impossible. On the other hand, an explanation of the fundamental things that undergird our existence is quite possible. Of course, such an explanation could only come from someone who actually knows what is going on at the fundamental level, and I am one such person. I know about the fundamentals because someone else who knew explained it to me, and it made perfect sense. It also erased all of the uncertainty that surrounded the framework for the early discussions about relativity. So, let's get right to it. Let me explain what the fundamentals really are. To understand any of the fundamentals, you must know what forms energy can take at the fundamental level. There are only three. Number one is the energy ocean. Space is filled with energy. We exist in this ocean of energy. It is established and maintained by the normal processes of light, which is entirely a particle phenomenon. Photons have been emitted from every star that has filled the sky for billions of years. All of the more recently emitted photons have to push their way through this ocean of photons that were already there, causing them to lose energy in quantum leaps in the process. So, the energy ocean not only fills the immensity of space, it is being constantly replenished with new photons from stars that continue to exist. And the quantum leap process ensures that the energy ocean will always contain a wide range of photon sizes and speeds. The second form of energy is the tornado-like structure of all particles. All atoms are tiny tornadoes of energy spun from the photons that make up the energy ocean. Different size and shape energy tornadoes represent the different elements. All other particles are fragments broken off from atoms and other particles. No particle has any other form than that of a tiny energy tornado. In essence, all things are made from light, and mass is simply a measure of how much photon energy is swirled and compressed into the walls of the particle tornado. Without mass, there is no particle. And the third form of energy is velocity. Our velocity through the energy ocean keeps our atomic tornado spinning like a pinwheel held outside the window of a moving automobile. Velocity is the c² in Einstein's famous equation E equals mc squared. This velocity is what I call a foundational variable. Whatever the current velocity, it establishes the current mass of all our atoms, and it is the basis for all the laws of science. We exist in a relative universe, and this velocity establishes our current relative values. This velocity is the controlling factor in determining how much photon energy can be absorbed and maintained within each particle tornado. The entire universe continues to exist because of its velocity through the energy ocean. It also slows down because of friction that accompanies this motion. When we slow down, every atom loses some energy, and we, along with the entire universe, get smaller. We do not notice this reduction in size because all the laws of science remain the same regardless of the speed of the observer. All of our measurement devices get smaller as well. It is kind of a universal trade-off. We continually give up some of our mass in order to maintain our existence. Relativity maintains the illusion of an unchanging stability. At the fundamental level, there are no other forms that energy can take and no other substances to add. These three fundamental forms of energy are the basis for explaining all fundamental and near-fundamental phenomena, large and small. It is the closest that science can ever get to a theory of everything. Except, of course, that it is not a theory, it is just the way things really are at the fundamental level. I refer to these three forms of energy as fundamental truth. Now, armed with fundamental truth, I will explain the mysteries and correct the wrong assumptions that formed the framework for the early discussions about relativity. Space is not empty, it is full of photon energy. Mass is a measure of how much photon energy is swirled and compressed into the walls of each particle tornado. Mass is not only affected by, it is actually determined by velocity through the energy ocean. Now, there is no such thing as rest mass. Something may be at rest with respect to the Earth or some other reference point, but if anything was at rest with respect to the energy ocean, all of its atoms would unravel and their photon walls would just fade back into the surrounding energy ocean. Because I have access to fundamental truth, I know things, not necessarily related to relativity, that may be helpful. Space is not empty, it is full of matter and energy. The atom percentage of 4.9% may well be reasonably correct, but the other percentages are based on some assumptions that are not correct. Dark energy, at 68.3%, is an unknown form of energy that supposedly permeates all of space and accelerates the expansion of the universe. The notion of the expansion of the universe is based on the observation of a red shift in the light spectrum from distant stars. Scientists attribute the red shift to the Doppler effect applied to light waves. But light is not a wave, so the Doppler effect does not apply. The red and blue shifts are due to relativistic differences between us and those distant stars. The universe is actually shrinking. And that will become obvious as you continue to listen to my explanations. Energy does fill the immensity of space, but it is not unknown. It is light. Photons of light fill space. Dark matter, 26.8%, is imagined to exist to explain the celestial swirling motion. It is assumed that gravity alone is responsible for this motion, and the 4.9% atoms are simply insufficient to account for all that motion. This reason for dark matter is unnecessary because gravity is not the only force influencing celestial motion. There is a tornado-like structure operating at the large end of existence as well as at the small end. Tornadoes within tornadoes within tornadoes is the nature of the infinite structure that is the foundation of the universe. Now let's review the primary relativity discussion areas that are traditionally addressed. First, let us consider relativity of simultaneity. Wikipedia defines it as follows. Observers who are in motion with respect to each other may disagree on whether two events occurred at the same time or one event occurred before the other. I have no quarrel with this statement, although the calculations as to the differences may or may not change when the true nature of light is considered. Time dilation is explained as follows. An observer watching two identical clocks, one moving and one at rest, will measure the moving clock to tick more slowly. Now this is a very cautious statement. It does not make it clear whether or not they think the moving clock is actually ticking more slowly or just observed to tick more slowly. The most convincing evidence that time dilation actually occurs is demonstrated by atomic clocks aboard GPS satellites. Special relativity predicts a slowdown of 7,200 nanoseconds per day due to increased velocity. General relativity predicts that time will speed up by 45,900 nanoseconds per day due to lower gravity. This is a net difference of 38,700 nanoseconds per day. This difference is verified by comparisons to Earth-bound atomic clocks. Now, engineers slow down the satellites by 38,500 nanoseconds per day to keep them synchronized with Earth time. So we have continuing evidence that time dilation is a real and measured effect. If this evidence had been available to Einstein in 1948, it might have helped swing his decision from introducing the false notion of relative mass to supporting his observations and equations predicting that mass actually changes with velocity. The twins paradox predicts that if one twin remained on Earth while the other traveled in space at speeds significant to c, when the traveler returned, his twin would be years older than himself. The paradox, when possible to test, would likely prove to be true. Body clocks as well as atomic clocks would be affected. However, it is conceptually possible to shield a traveler and his spaceship such that neither mass changes nor time dilation would occur. You just have to understand how and why mass and time change with velocity. Relativistic mass. This concept apparently remains misunderstood in today's science. Scientists are still uncertain as to whether or not particle mass actually fluctuates with velocity or if mass only appears to change because of momentum. Mass actually varies with velocity, and when you understand the purpose of relativity and the way it is implemented into the fundamental structure, the mass changes make perfect sense. It is impossible to realistically consider that all the laws of science remain the same regardless of the speed of the observer if mass does not change with velocity in ways that are indistinguishable to the traveling observer. Consider this situation. A spaceship takes off from Earth and accelerates to 86.6% of c. At that speed, its mass would double. Then it stops accelerating and coasts at that same speed. It is now a non-accelerating reference system, and all the laws of science are the same as before it left Earth. Now, does the spaceship's mass remain double, or does it revert back to its original mass before it left Earth? When serious discussions about relativity began, space was assumed to be empty, so velocity with respect to what was a question that went unanswered. And that is why many of the early discussions centered around the velocity of one observer at rest viewing something else in motion. Velocity with respect to each other was the assumed basis for the discussions. But when it was concluded that space was not empty, in fact, it was filled with energy, an ocean of energy, velocity with respect to each other needed to be changed. Now it becomes clear that the basis for discussions on relativity should be velocity with respect to the energy ocean. And that is why the spaceship, coasting at 86.6% of c, remains at double its initial mass. And it is now zero velocity with respect to a new value of c, because it is its own non-accelerating inertial reference system. Length contraction is explained this way. Along the direction of motion, a rod moving with respect to an observer will be measured to be shorter than an identical rod at rest. It is incorrectly assumed that mass does not really change with changes in velocity. The interferometer tests used to validate length contraction are the same tests used by Michelson and Morley, and based on their results, they concluded that space was empty. They were wrong, and so are today's scientists. While the speed of light in a vacuum will always measure as c, the photons that actually deliver the light may well be traveling at significantly different speeds under different relativistic conditions in order to make light appear to be traveling at a constant c. C is a relative constant, and it changes along with velocity. Mass actually increases with velocity, and so would the mass of the rod. At speed c, the mass of the rod would be infinite, and its dimensions would stretch in all directions as far as the eye could see. No one would think it was contracting. The equivalence of mass and energy, written as E equals mc squared. Now, I have no reason to doubt this equation. The only new information that I can add is that c square is the velocity at which we are currently traveling through the energy ocean. It is what I call a foundational variable. Whatever speed we are traveling, it establishes the current relative values of all our atoms. Any atoms that might be used in a detector to measure the speed of light would always measure it as c. And anyone bright enough to understand the equivalence between mass and energy would determine that E equals mc squared. And this will always be true at any speed we might be traveling through the energy ocean. My purpose in reviewing the assumptions that framed the early discussions about relativity is twofold. First, to point out that several significant assumptions were wrong and should be replaced with new assumptions. Primarily, light is entirely a particle phenomenon. There is no electromagnetic wave. And velocity with respect to the energy ocean means that mass really does increase with velocity. The notion of length contraction is false, and the tests that are used to support it, while performed and measured with great accuracy, was conceptually flawed. Secondly, to frame new conditions for observing objects traveling at velocities significant to c. For all of my discussions, there will be an observer on one traveling object who will be subjected to changes in both mass and time. This observer will not notice any changes due to changes in velocity. All the laws of science will remain the same. He will not feel any different because the changes in mass and time. To him, it will seem as though nothing changed at all. Now, traveling close beside him at the same speed are other observers who are shielded from those relativistic changes. They can measure mass, distances, and times using devices that are unchanged by changes in velocity. and their observations are not skewed by variations in speed or great separations in distance. They should see precisely what is predicted by well-known and trusted equations. Using some new thought experiments, I will dispel some long-held but mistaken notions about the fundamentals. I will also explain the true nature of light, the atom, how relativity is incorporated into the fundamental structures, and how inertia and time dilation actually work. And even though gravity is not normally included in discussions of special relativity, it is easy to explain, so I will explain that as well. Also, scientists have created small fusion reactions and particle accelerators and learned that energy can be released by such reactions. They have been trying, but failing, for over 50 years to create a sustained fusion reaction that produces more energy than is required to create it. The primary reason for this failure is that they think the atom is one kind of thing, but it is actually something quite different. When the truth is known, you will see that fusion is not really such a great idea. There is a much better new source of energy to harness. And I realize that my explanations about the fundamentals are quite different from what is contained in existing science books and taught in high schools and universities around the world. At this point in time, the scientific community does not have a realistic grasp of the fundamentals. But they need fundamental truth in order to extend the habitability of this planet. And even if they embrace fundamental truth, they may yield to economic and political pressures and do nothing about it. In one sense, this is somewhat like a final exam. If they pass, we get to occupy this planet a little longer. If they fail, some may be chosen to find and settle another planet, but a lot more of us will simply make room for the next round of civilizations. In the video segments that follow, there will be a lot of repetition, and this should be expected because all fundamental phenomena must be explained down to only 3 fundamental forms of energy. Also, these segments were not all developed in the same sequence as they are now presented. But in the future, I may try to reduce the repetition and present the various concepts in a more orderly fashion, but what is now presented is sufficient to give open-minded scientists a better foundation for understanding the fundamentals. The misunderstanding of light is responsible for many of the conceptual errors in the current notions of relativity, mass, and energy. That's why 4 of the first 7 segments deal with the fundamental nature of light. Now, Part 8 will explain gravity, and Part 9 will point out problems relating to nuclear fusion. Future releases will explain the other remote forces, magnetics and electrostatics. And while scientists have made remarkable progress using these forces, they have yet to explain how nature actually works to manifest them. They will need this knowledge to develop and introduce new technologies necessary in prolonging the habitability of this planet.